Hi, everyone. Welcome to STEPCON, the Science and Technology Educational Partnership. I'm Barish. I'm a professor of physics here at Riverside, and I have a great interest in technology and what you're learning. I think it's a fantastic opportunity for all of you, and I'll try to just give you reasons why. First, STEPCON itself is sponsored by by CERT, the high school virtual learning module. It's a high school virtual learning module, and it's sponsored by our hosts who are behind me. That unfortunately we're virtual, but this is the Bourne College of Engineering at UC Riverside, and also the Center for Environmental Research and Technology. The approach this week that you're going to get is really a hands-on introduction to the high technologies, some of the high technologies that are moving our society forward, that are where you'll be years from now. I mean, now in high school, you study mathematics, chemistry, biology, maybe physics, and you'll get to college and study engineering. All this is very academic. And this week, you get the opportunity to do something much more hands-on and much more introductory to where it all ends up when some of you, hopefully a lot of you, end up going into science or technology and engineering. So this week, we'll find that you'll interact and learn with learning modules and then hands-on experimental work. And the fields are a variety of ones that are really right there where we are moving the world and our society ahead from where we are now. The first one, hosted by Matt Barth, who's the director of CE-CERT, is on smart cities and transportation. So smart cities and transportation is a buzzword, of course, but it's a very important concept that now is being used in the design and making cities work. For example, in transportation, which you'll learn about by making it intelligent enough to satisfy the needs much better of the population. Interestingly, I personally have some experience with smart cities in Italy. I do a lot of my research in Italy, and there's two different places in Italy that are doing very advanced work in applying smart cities. One is a city called L'Aquila, which was near the laboratory I work in, which was destroyed by an earthquake about 7 or 8 years ago. And in rebuilding the city, they have a lot of attention to rebuilding it in a way that's a smart city, in terms of the transportation, the communication in the city, the interaction and design between the commercial part and the residential parts, and so forth and so on, the kinds of things that you'll learn. The second place in Italy, just happens, my experiences in Italy, is in Milan, where they had, some of you might have possibly been there, they had a World's Fair for about 10 years that ended in 2015. And now they're taking the land, a large piece of land in fairly central Milan, and redeveloping it into a residential, commercial, and research place with a research hospital, for example. And it's being done as a smart city with a lot of attention to the internal transportation modes, things you'll learn about this week, and so forth. So I think, learning about smart cities is one of the most forward-looking things you could do, and those of you taking that will learn about that this week. The second one, which also is an area that I have a touch with, is artificial intelligence and machine learning. That'll be hosted by Barak Galler. She's an assistant professor of electrical engineering and computing here at UC Riverside. And machine learning and artificial intelligence are an area that had great promise for years, a lot of hype about what it was going to be used for, but now we're there. So The tools that were needed to develop machine learning and artificial intelligence have really come into their own in the last decade or more. It's as many uses, everything from using them in old people's homes to transportation or, um, for example, autonomous vehicles, or even in sciences. I use artificial intelligence or machine learning to study what we call glitches, which is kind of what the device develops as background for doing the science we want in our gravitational wave detectors. So it's used from the most advanced science to kind of practical things for all of us. And you'll use Python, which is the tool that we all use to use machine learning on some nice examples. The third area I know a little less about is microgrids. And that's important and becoming more and more important because of the fact that locally, in any sort of local community, we're starting to use renewable energy much more than we did in the past. And renewable energy has this feature that it's intermittent. It gets a lot of it when the sun shines or the wind blows, and less at other times. And so you need some way to be able to handle the ups and downs. And a microgrid is a connection locally that uses these features to run everything locally, and then it has to connect to the bigger grid where when it has an excess, it puts power back into the big grid. And when there is less renewable power, it comes into the local grid. And so you'll learn and do projects simulating some microgrids, which is more and more going to be and is an important topic. Sadrul Ula, who is an expert in this area, will guide this part of the project. Lastly, there's a clean air section. I think that's subscribed. It's got to do with using little devices and measuring air quality, something that we're all reminded of and have been in the last weeks with the forest fires in California, how important it is. And an expert in that area, and you'll again be hands-on, will be guiding that, and that's Nicole Cleary. So those are the areas. And all of you will have learning modules to learn about it, and you'll have projects that you work on. The projects will then be evaluated. The best ones will move forward to some final judging, and then on October 16th will be an award ceremony for the best work that we've done. That's all I have to say as an introduction. Take advantage of all this. It's a wonderful experience to have so young and give you some guidance, and absorb it, and most of all, have fun. Good luck. Bye-bye.
Hello everyone, I am ASM Jahid Hasan. I am a graduate student at University of California, Riverside, and I am doing my PhD in electrical engineering. Here I work at CE-CERT, which is College of Engineering, Center for Environmental Research and Technology. I work with the CE group here, which stands for Sustainable Integrated Grid Initiative. We work the electrical grid, renewable energy such as solar, battery energy storage, and we do building energy management, and we work with the electric vehicles. So why did I choose this field? I'm from Bangladesh. It is a small country, but it is one of the fastest growing economies in the world. To keep this goal, we need more industries, and industries need power or electricity. We can get electricity from either fossil fuel-based power plants or renewable sources, such as solar or wind. So these fossil fuel-based power plants, they cost a lot of money, they need infrastructure, and they are not very environmental. But the renewable sources, on the other hand, are very much environment friendly, and their costs are also going down in recent times. But still, there are many challenges in using these renewable sources. So Like the generation is dependent on the weather condition. They cannot generate a fixed amount of electricity output all the time. Like solar generate electricity at only daytime. So at night time, the production becomes zero. So what do we do when we require it at night time? Batteries can store electrical energy and can provide it whenever we need it. But there are also some costs associated with this battery. So what type of battery, what size of battery we need to use so that we can make a system economically feasible while also meeting our electricity demand requirements. So these sort of things need to be figured out. And with all the global warming, climate change, and other environmental concerns, and the increasing demand of electricity in our modern civilization, these sort of works are very much relevant and tremendously important in today's world. I hope that my works will help in this process and I can contribute something towards my country and to the world with my works. And science and math background is needed if you want to go into this field. So many theories and concepts and applications of science and math helps me every day in my research challenges. And I also hope that this knowledge can help others in their works too. So thank you very much for your time. Stay safe. Bye.
Hello everyone, my name is Enriquez Contreras. I am a second year PhD student at the University of California, Riverside. And today I will introduce you to my research here at UCR. This is the basic layout for our research here at UCR. So I work at CE-CERT. So CE-CERT, basically at UCR we have different colleges. So we have the College of Humanities, College of Natural Science, but I work with the College of Engineering, the CE, and essentially CE-CERT is the Center for Environmental Research and Technology. So we're doing all of the things you'd probably label as green. So we're figuring out how to use different technologies to implement newer technologies that would be considered green. So in particular, I work with renewable energy, or essentially sustainability. So anytime you hear about windmills or solar farms or anything has to do with renewable energy, we're kind of experimenting that here at UCR. So what we're doing is a microgrid. So essentially we're doing a small simulation of what, like, let's say in the future, maybe all of Los Angeles will have solar panels and windmills. We want to see how that works on a smaller scale. So here at UC Riverside, we're actually doing that with our own university. We're making it into a microgrid. So we're implementing solar panels, windmills, and even batteries for renewable energy. Essentially, we're combining all these technologies together and see how they interface. So this is what you can see here. Here you first see Riverside Public Utilities. Riverside Public Utilities is basically, if you live in the Riverside area, this is basically the electric company. So this is just your typical gas burning provider for us. So essentially this is when if you don't have any renewable energy and you just connect to the grid, this is kind of the traditional system we have. And now this is where it gets interesting, all of our renewable energy. So we have 2 solar farms here at UCR that we work with in particular. One is at CE-CERT, which is kind of the off-campus facility. So in our parking lot, we have all this nice shade provided by these solar panels. However, those solar panels at the same time provide us with a lot of energy. And we have another array of solar panels at UCR, but also at the parking lot. So lots of this free shade also gives us free energy, which is very nice. We convert this DC energy into AC power, and we send that to, let's say, either UCR or batteries. So let's say if we're producing more electricity than we need, we can actually charge these batteries. So like, let's say during the night when we don't have solar, we can actually use solar energy at night by charging these batteries. So that's kind of the basics. We're trying to see how we can interface all of these together. What interests me in my work? So what's very interesting about this is that we're basically on the frontier of a new technology. Well, we heard of solar panels before, windmills, and it's been done before. Nobody's really integrated that yet. I mean, there have been other universities doing smaller models, but we're like, if you ask any city, like if some city comes up to us or any group in general, like how would we do a microgrid? There isn't an exact answer yet. There's multiple ways of doing it. And I think the question now is which way is the best? And while we can kind of have an educated guess, our research is to kind of have a better answer for that. So, and another reason I like it, since I like thinking a lot, so I like trying to figure out problems. I know it might sound a little weird of somebody saying I like problems, but it's fun. I think for me, I enjoy having a problem. Okay, we have this problem. How do I solve it? And if you really enjoy that, I think engineering and science in general is a great place to be, since you're always asking questions and always trying to figure out solutions to problems. We all enjoy that in engineering, and I think that's the fun part of it. And another reason I like where I'm working at right now is it combines multiple skills. Since I work with inverters, I work with solar panels, I work with computer programs to run them, I work with the circuits needed to connect all this together. It combines a lot of different skills. Like I need to know programming, I need to know the code, I need to know how to design circuits, I need to know how to do math, and I even work outside. I need to actually know how to use tools. I'm actually in the sun out sometimes, so it's a very interesting workflow. It's not just me knowing one skill. I need to use multiple skills to work where I'm at. So what impact does all this of our work have? So I think most of you know renewable energy is kind of a important goal right now, and I believe California is trying to go try to replace lots of its fossil fuel based energy with renewable energy. So governors, politicians will say, we want, let's say California wants to be 50% renewable by 2030, for example. That, they might just state that goal, but that's a very complicated thing to actually achieve. And while the politician might sound very heroic for saying that, the real magic happens with engineers. The engineers in the background are ones who have to figure out how do we do something, how do we do that in that time frame, and how do we make it work? Not that it just works, but it's stable, and it can, not only does it shine during like normal use, but in extreme cases, how will this new system handle an extreme situation? So the best legacy we can provide to future generations is work now, so the impact of climate change is mitigated with our research. I'm just saying you should enjoy just STEM in general, what power it gives you to help change the world. But that being said, I also would like to introduce you to renewable energies, to power systems, which maybe you've never contemplated before as a field you can get into. So I just hopefully this kind of gives you a very brief sneak peek of what that would be like. So I hope you enjoyed this quick introduction, and have a nice day.
My name is Sadrul Ula. I'm a research faculty at University of California, Riverside, Bourne College of Engineering. Research Center, Center for Environmental Research and Technology. My area of expertise is sustainable, renewable electrical energy. Can you imagine cell phones, tablets, laptops, desktop computers, they all run on electricity? A life without TV or games, can you think about it? What about a heart or brain surgery without electricity? No traffic lights, refrigerators, air conditioners running as there are no electricity available. And this is what we faced in California's rotating blackouts about 3 weeks ago. Now let's think about where do we get our electricity from? Traditionally, in old days, we got electricity only from burning fossil fuels like natural gas, coal, oil, and some with nuclear power. But they all have negative environmental impacts. The fossil fuel burning pollutes air, water, and other environmental impacts. Nuclear has nuclear waste and radiation handling issues. So we have been looking for alternatives, how to move away from dirty fossil fuels into renewable, sustainable energy. Now, what are those? There's solar photovoltaic electricity, wind power generators, there's hydroelectric power, some of which were available before in the mountains and large dams, and geothermal energy underground, deep underground earth. So these are renewable and have very minimal environmental impacts. But one of the challenges of renewables like wind and solar is that they are intermittent. They are there when sun is shining. At night they are not there, or if there is a cloud cover, they are not there. Wind is there sometimes it's not there. So if we rely on these cleaner renewable energies which are sustainable, then what do you do when they are not available? So part of my research is to try to integrate these different technologies and focus partly on energy storage. Battery energy storage is the best available electrical energy storage. And when we have surplus renewable energy, we charge batteries. Then when the solar energy, wind energy is not there, we can get the energy back delivered, and thereby we are with electricity 24 hours a day throughout the year. But some of these newer technologies offer challenges of integration, when to charge, when to discharge, what type of optimal controller to use. And my colleagues and I at UCR are working to solve these issues and come up with an optimal solution so that we can integrate these cleaner energy technologies for a sustainable future. One of the system we developed is a smart microgrid which can rely on solar and battery energy to supply a portion of our requirement in amongst the many buildings we have. One of the research buildings, headquarters of our Center for Environmental and Research and Technology, depends on this microgrid. Even when the grid power is not there, it can operate normally. We need multiple microgrids throughout the state to be able to rely on renewable energy and move away from fossil fuel and go towards a sustainable future. For that, my colleagues and our students, they all prepare with high school science and math and engineering and technology oriented courses so that we can work on an overall system which is beneficial to us, at the same time not harmful to the environment. So we are looking forward to share some of these exciting research and development demonstration we have at our research center. Look forward to spending the next few days with you. Thank you. Bye.